Welcome back, guys. Last time we talked about polynomials, where we discussed monomial, binomial, trinomial, and more and more and more. We talk about the leading coefficient. We talk about the degree of the polynomial. We talk about the constant. We talk about adding and subtracting polynomials. And we also talk about multiplying polynomials. So today, we're going to be talking about factoring polynomials. Okay, using a method called the greatest common factor, the GCF. Okay. But what is factoring? Factoring basically is like to share, have something in common. Okay, whatever they have in common, whatever they need, the common need is, they could share that. Okay. Think, for example, at school we have a big copy machine. Okay. Instead of having a copy machine for each teacher, we just need one or a few for the whole school, so teachers could go and make copies. Or in a house, let's say you have a printer. Just need one printer for the whole house. You don't want each one to have their own printer in their room. Okay, so same thing as having one kitchen. We don't need a whole bunch of kitchen in the house. We just need one or a TV. Okay, if you really think about it, just have one TV in the living room, and when it's time to watch TV, everybody goes there. That's a common need. Versus having TV in each room. Just have one, then everybody goes and share. Okay? So if you think of factoring that way, then you'll be just fine. Okay? We're going to go over common factors, something that they have in common. Okay? Let's take, for example, the number 16. Right? If you take the number 16, 16 is the multiple of 1, the multiple of 2, right? Multiple of 4, multiple of 8, or multiple of 16 itself, right? 1 times 16 is 16, 2 times 8, 16, 4 times 4, 16, 8 times 2, 16, 16 times 1, 16. Okay? If we take the number 20, let's pick 20. 20 is a multiple of 1, or 2, or 4, right? Or 5, or 10, or 20 itself. Right? So if I take 20, I could say 1 times 20 is 20, 2 times 10, 20, 4 times 5, 20, 5 times 4, 20, 10 times 2, 20, 20 times 1, 20. So if we look at these two numbers, 16 and 20, we try to see what they have in common, what factors they have in common. That's what we call common factors. So they both have 1 in common. They both have 2 in common. They both have 4 in common. And that's it. They don't have anything else in common. So if we want to find the common factors of 16 and 20, that will be 1, 2, and 4. Okay? So 1, 2, and 4 will be our CF. CF for 16 and 20 is 1, 2, 4. So 1, 2, 4. Okay? So that's really easy. So looking for the common factor is looking for what they have in common. I could say, for example, for what we want to do in Algebra 1, we want to factor, right? So I could say, for example, we have this example. Factor 16x squared, I'm using this 16, plus 20x. Okay? So basically we want to see what numbers they have in common and put that number outside. So if I look at this one, 16 and 20, okay, we already know they have some numbers in common. But we want to look at the biggest number they have in common. The biggest number they have in common is this one, it's 4. Okay, so we're going to say 4 times 4 times x here. And this one will be 4 times 5 times x. Oh, actually, we have 2x here, so one more x. Okay? So if we take 16 and we break it down, we get 4 times 4 times x times x. If we break 20 down, we got 4 times 5 times x. So we're going to see now they have 1 4 in common, and they have 1 x in common. Okay, so we're going to write here our answer, what they have in common, 4x, right? 4x. We leave it outside. And whatever is left over, we put that inside. So here we have 4x that is left. We're going to put that inside. 4x. There's a plus there. Plus. And here we have 5, which is alone. 5. See? So if we were to factor 16x squared plus 20x, this will be our answer. 4x parentheses 4x plus 5. This is our answer. We just factor this. Now, let's talk more about the greatest common factor. The greatest common factor is only one. Okay? For common factors, we have different numbers. But greatest common factor is only one. So in the example that we just did, the greatest common factor was the biggest factor they have in common. Okay? So let's talk a little bit more about it. Let's say we want to find the greatest common factor of 16 and 28. Okay? So 16 we already know. 16, when we break it down, is 1, 2, 4, 8, 16. Okay? That's that one. Okay? What about 28? Okay? How can we break it down? We could break it down 1, 2, 3, no, 4, yes, the multiple of 4. What else? Maybe 7, right? 4 times 7, 8, so 7. And I think, what else do we have? 14, we have 14, and we have 28. I think all these are multiples. So we look at all these, and we see that 4, just like before, is the biggest factor here, okay? The greatest factor. So we want to focus more on the biggest one, 4. Okay? This is the multiple of 8, 16. This is multiple of 7, 14, 28, but we don't need that because the biggest one they have in common is this. Okay? So, for example, if they say factor, use a different color, factor, let me say 16x squared System x cubed minus 28 x squared. Right. So this is what we have. We're going to look at the greatest common factor, which is 4. Right. We take that 4 right away. Find the multiples. So that will give us 16. So 4 times 4 is 16. We'll do the same thing here. 4 times what gave us 28? 7. So 4 times 7, 28. Then we break down the x cubed and the x squared. So x cubed means x times x times x. X squared means x times x. Okay? So now we look and see what they have in common all together. Okay? So they have 1, 4 in common, and they have 2 x's in common. So 1, 4, and 2 x's. Okay? So 4x times x, 4x times x, so that's 4x squared. So they have 4x squared in common. We're going to leave that outside. 4x squared. Whatever they have in common, remember, it's public property. Okay? It's in the living room. It's for everybody to share. So whatever they have in common, stay outside so they could share. Whatever is left over is private. It goes inside the room. Okay? So we have 4. We have one more 4 here and one more x. So 4x is left over. That's private. It stays here inside the room. Okay? And now we go here, we have 7, and there's no x, right? Just 7. So 7. And in between, there's a minus. This is the factorization of 16x cubed minus 28x squared. Okay? Your answer is 4x squared, parentheses 4x minus 7. That's what they have in common, 4x squared. Okay? What they have in common, stay outside. Whatever is left over goes inside the room. Okay? Another way of doing this is the generic rectangle. Okay? So this is an example. For some people, okay, it might be easier to do this. Draw a rectangle. This is a binomial. Right? It's 2. So I'm going to divide this into 2 because it's a binomial. First one goes here, 16x cubed. The second one, negative 28x squared. Okay? For some people, this method might be easier. Okay? So you look at this horizontally here. Horizontally on this line, what do they have in common? Whatever they have in common goes here. Okay? So if you want to go a little faster, if I know my multiplication table, 16 and negative 28, they have 4 in common. Okay? Boom, 4 goes here. That's the greatest common factor. Then I look at x cubed and x squared. What do they have in common? They have x squared in common. There we go. So 4x squared. Boom. Now I'm going to tell myself, I'm going to ask myself, 4x squared times what gave me 16x cubed? 4 times what gave me 16? 4 times 4. X squared times what gave me x cubed? X squared times x. Let's see. 4x squared times 4x, it is 16x cubed. So that works. For some people, this method is better. Now let's look at the other rectangle. 4 and negative 28. 4 times what gave me negative 28? 4 times negative 7. 4 times negative 7 gave me negative 28. X squared times what gave me x squared? X squared times 1. Okay? X squared times 1 give me x squared. I could put the 1 here if I want to. That's it. So 4x squared times negative 7 is negative 28x squared. So again, your answer is 4x squared, which is like the length of, one side of your rectangle, length times width, 4x squared, times this, 4x minus 7. Because 7 times 1 is just 7. This also is your answer. For some people, this method is better. Okay, so this is our answer. Okay? So I'll show you 2 ways of factoring this. Okay? You could do it directly like this, or you could put it inside the box. This box is called the generic rectangle. Okay, generic rectangle. Generic rectangle. Okay. So the rectangle is basically giving you length times the width. So we have the length times the width. Okay, the length times the width to get what is inside. What is inside is called the area. Okay, so it's basically finding the area of a rectangle. Okay, the area, we break it down into length and width, and that's our factors. Okay, all right, let's move on. Okay, so on the last example, we just factor 16x cubed minus 28x squared. Okay, we did 2 ways. We did the horizontal one and we did the generic. Let's do this one, 14x plus 35. That one is easy. B, 14x plus 35. Okay, we want to see the multiples, okay, that they have in common. 14 is basically 2 times 7. And x is there, times x. Okay? 2 times 7, 14 times x, 14x. What about this one? This one, 35 is multiples of 5 and 7. So 5 times 7. Okay? So we look at this, and we see that they have in common 7. The biggest number they have in common is 7. So we put the 7 outside. Okay? Whatever is left over, we put it inside, just like before. Okay? So we have 2x, which is left over. It goes inside. Plus, don't forget your plus now, 5. And this, my friend, is your answer. You just factor this by using the greatest common factor, right? 7. Okay, let's look at C. C is 9y squared minus 33. Okay, we're going to do this in the same fashion. Okay, we're going to break it down, find the GCF, now that we know how to find it, because we know our multiplication. 9 is 3 times 3. 3 times 3. Y squared is y times y. 33. How do we break that down? 33, I know my multiplication table. It's 3 times 11. 3 times 11. Okay? Now that we broke everything down, we could see that they have 3 in common. Remember, whatever they have in common stays outside, so everybody can have access to it. Whatever we have in common, 3, it stays outside. 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 Or in the living room. Living room. Okay, so this is the living room. Anything else, go inside the private room. Anything else that is not in common. Okay, all right. So this 3 is outside because they have in common. These 3 and the y's, they go inside. So 3 times y is 3y, times y, 3y squared. So 3y squared is private. Here we have 11, which is private too. So 11 goes there. And let's not forget our minus. And guys, this is your answer. Okay, one last one, D. D. Factor 20m squared plus 45m. Okay, I'm going to check. Okay, 20, we could break it down. 20, 20, 20, and 45. Ooh, I know my multiplication. I could break it down quickly. 20, if I go down low, low, low. Oh, they have 4 in common. 4 times 5 times m times m. I look at 45. I know they have 5 in common. So it's 5 times 9 times m. Because I know my multiplication table. Okay? All right. What do they have in common? Ooh, 5 and 1m. Whatever they have in common, we leave it outside in the living room. The living room right here. 5m. 5m. Anything else goes inside the private section, the room. Okay? So we have 4m plus, here we have 9. There's no m left. And this, my friend, is your answer. Okay, you just factor using the GCF, the greatest common factor. Okay, let's factor using the generic. I have one good example here. We're going to call this one E. Okay, so E. Draw my rectangle. Have x squared here. Have 3x here. Have 2x here. And I have 6 here. Okay. All right, let's see. So when we have something like this, we can look vertically what they have in common. Then we can look horizontally what they have in common. Okay. So vertically, what do we have in common here? I have x squared and 2x. They have one x in common. That's easy. Vertical here, 3x and 6. What do they have in common? 3x and 6. They're both multiples of 3. They have 3 in common. 3. Okay. There's no x here, so there's no x. Okay. Right. Now let's look horizontally. X squared and 3x. X squared and 3x, what do they have in common? They have one x in common. Okay. There's no 3 here, there's no number, so they only have x. That's easy. And let's look at the other one horizontally. 2x and 6. What do they have in common? What is their multiple here? They're multiples of 2. Right? There's no x here, so we could say they just have 2 in common. Now let's see if this thing makes sense. X times x, x squared. Oh, that works. X times 3, 3x. That works too. 2 times x, 2x. We're on the right track. 2 times 3, 6. Guess what? We could just put plus here. So x plus 3. This is one of our answers. X plus 3. Here's the other one. Oh, we could put plus in between because there's no minus, right? So x plus 2. X plus 2. Okay. So here we use the generic rectangle method to factor this. Okay. So later on you will see solving by the diamond, right? The X method. Right? The X method allows us to create the blocks called the generic rectangle. Okay. And we'll talk more about this with the other teachers. Okay. You'll see the X method. The X method will lead you to the generic rectangle. Okay. So you'll be able to factor. All right. So guys, this is basically it. We're done with factoring by GCF and a little bit of a little quick introduction of the generic rectangle. Okay, those approaches are good approaches for you to factor correctly. Okay, if you get stuck, don't forget, just go back, rewind, watch it again, and I'll see you in the next class. Bye-bye.